All right, IB AI SL1. Well, not AI. IB SL1. There we go. Today we're going to do 2.4. So we're going to talk a lot about domain and range. That's our main topic. Domain, it means everything that can possibly go into a function. It's all the possible inputs. Another word that we're going to start using is the independent variable. I don't think we've said that yet, but it's the same thing as x in most cases. And then the range is all the possible outputs of a function, or in this case, we're going to say all the possible values of a dependent variable, which is usually the y. There's IB notation. There's like 3 different ways to annotate or notate domain and range. You can do it with these alligators. Less than or equal to, greater than or equal to, less than, greater than. Also, that's just me calling them alligators because they look like little alligators. So you like put a little eye here and then teeth. Yeah, it's an alligator. But these are technically called inequalities. You can use inequalities for domain and range, or you can use some combination of the British bracket style or the American parentheses style. I realize the American style uses brackets and parentheses, but the British style strictly uses brackets. And I'm going to show you guys the difference between the two with a few examples. So, some notation examples. On the left, I have how you would say these things in English, like x is less than 3. And then in the middle, I'm going to show you guys how to write them with alligators, with the inequality. And then on the right, I'm going to show you interval notation, both British and American. So x is less than 3. That would be x is less than 3. Here's the alligator version of it. Remember that the alligator always wants to eat the bigger number, so this would mean all the numbers that are less than 3, smaller than. The interval notation is going to be negative infinity all the way up to 3, but not including 3. So that's the American style. The other style you can do is the British style, where you can say an uncovered negative infinity all the way up to 3, but not including 3. So notice that I'm putting the bracket so it doesn't cover the 3. So here, like if I had written, here, let me delete for a second. If I had written it like this and put the bracket over the 3, this means that it includes the 3, but we cannot include the 3. It's everything up to, but not including the 3. So you have to turn the bracket around. The American version is they just use that good old-fashioned parentheses to say that it is not included. If it was a bracket, it would be included. The next one says x is less than or equal to 3. Well, here's the alligator version. X is less than or equal to 3. Now, the interval notations are going to be very similar. It's going to be negative infinity all the way up to 3. But now, in the American style, it includes the 3. So you turn that bracket around, or you make it a bracket. Or the British way to do this is to do not including negative infinity, because you can never truly include infinity, so it should always be uncovered, all the way up to 3, but now the 3 is covered, so you put a bracket around it. X is greater than 4. That way the alligator's eating the x, so it's greater than, so it's 4 all the way up to positive infinity. So the way you'd write that is that it does not include 4, and it goes all the way up to infinity, but you can never include a negative or positive infinity. So that's the American style. British style, we would start with 4, but an uncovered 4. So you'd say 4 all the way up to infinity, and infinity would be uncovered. X is between negative 1 and 5. That means it starts at negative 1 and goes all the way up to 5. You guys, if you are between things, you can never truly be at the endpoints. It's like saying, I'm between Bend and Portland. That means that you're not in Portland and not in Bend. So, yeah, the no or equal to's on the bottom, not inclusive. So if we're going to do this one, American style would be negative 1 all the way up to 5, not including. The British style would just be those turned around parentheses, or brackets, excuse me. So negative 1 all the way up to 5. Now the next one says between 7 and 9 inclusive. So that word inclusive means that it does include 7 and 9. So that would mean 7 all the way up to 9, and we're going to do less thans or equal to, because it can be 7 and it can be 9. That means for the American style, it will be 7 all the way up to 9. And for the British, it's going to look the exact same. Notice that the brackets are covering because they include 7 and 9. The next one says x is all real numbers. Well, here's the notation for that. X is an element of capital R, capital fancy R. This guy right here means is an element of. And then this fancy R just stands for real numbers. The way you would do this with the American style is you would say negative infinity all the way up to positive infinity, or the British style would just be those turned around brackets. So negative infinity all the way up to infinity, turned around bracket. So you have your choice when it comes to a lot of this stuff, unless they tell you to like specifically write in inequality or stuff like that, something like that. You can use American interval notation, you can use British interval notation, or you can use alligators. It's up to you. But you need to be able to understand the British one with the brackets. You can't just be like, well, that's silly, I'm going to do the thing that I already know. Like, they're going to throw it at you, and you need to be able to decode it. Domain and range. Because we haven't really done that yet. We've just done the notation on how we talk about it. First, we're going to look at a table example. Notice with the table example that they're just really coordinates. It's a table of inputs and outputs. So I know when I put in a 2, a 5, and a 7, and a 9, you get out a 3, a 1, a 5, and a 5. Now, the domain specifically is just going to be all the possible inputs. So here, we are going to do a curly bracket. Come on, Jolly. There we go. And then list all of the domain. 2, 5, 7, 9. For the range, it's going to be all of the outputs. 3, 1. And then you don't have to say doubles of 5. Don't put 2 5s in there. We'll just say 1, 3, 5. I'm putting them in order, just for fun. Actually, I think with sets, they should go in order. So put them in order. The mapping is very, very similar, that these are all your inputs, so these are your domain. So the domain is going to be curly bracket, -3, -2, 5, and 7. And then the output, the range, is all the possible y values. So this will be 4, 6, and 8. So domain can be specific discrete points. Oh yeah, these are called discrete points, because there's nothing in between them. Like there's no 2.5 or 2.9 or anything like that. Now let's look at an equation. Y equals 3x minus 6. Well, if I were to think about the picture of that, I know it crosses at -6 and then goes up 3 over 1, up 3 over 1. So it probably looks something like this. The domain for that, you can put in any possible x value. So the domain is all real numbers for this one. Let's say, we could say x is an element of R. We could say that it's -infinity to +infinity, or we can use the American -infinity to +infinity. It's all real numbers. The range is the same thing, that you can get any y value out of this, like because the arrows go, forever all the way up, and they go forever all the way down, so you can get any y value out of this as well. So we will say that the y is an element of capital R, or you can once again say -infinity to +infinity, or the American -infinity to +infinity this way. For the second example, it's a discrete graph. So it's just plotting points, but really that's the same thing as like a table. The domain is going to be all of the inputs. So the inputs are -4, -1, -1, 2, and 4. So a couple doubles in there. So we'll just say -4, -1, 2, and 4. The range is going to be all of these numbers. So -2, or +2, -2, -2, -2, and -5. So that's really just -5, -2, and -5, -2, and 2. There's your domain and range. Now, we're going to look at 4 different graphs and talk about the domain and range. Here's how I want you to think about these. So let's start with just the parabola. For domain, I want you to hold your pencil vertically and think like, so if you hold your pencil like this, and then you trace the function and go, okay, it's here, it's here, it's here. Like, see all the x values that I'm hitting? So like this parabola is going to go forever. It's going to expand forever this way and forever this way. So there's no x value that this doesn't hit. So the domain is going to be all real numbers. I'm just going to use the short version and say x is all reals. Now for range, you're going to want to hold your pencil sideways and think about all the different y values. So if I hold my pencil sideways and I touch here, it's touching all of these y values that go down all the way down to -infinity. Like these arrows continue, so it goes all the way down there. But then as I go up and up and up and up and up, sideways, 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 right about here, it stops. Jeez, come on. Calm down, please. Oh my gosh. So it doesn't exist above this point of 6. So it never gets higher than 6 on the y-axis. So we are going to say that the range goes from -infinity. Whoops, no curly brackets. Here, I'll use British style. -infinity all the way up to 6. And it includes 6. It does hit 6. So we use a covered parentheses there. We just did an example like this. It doesn't even matter like what the equation of this line is. Most lines, unless they're vertical or horizontal, are going to have a domain and range of all reals. So we'll say domain is x is all reals. And then for range, x is all reals as well. Ooh, a good old sinusoid, one of my favorites. When I look at this in terms of domain and hold my pencil vertical, like it hits all these x values and it's going to continue hitting all the x values to the left and to the right. So the domain is going to be all real numbers because there's no x value it doesn't hit. It keeps going forever to the left and forever to the right. So here the domain is x is an element of all reals. Now the range is actually interesting because if you hold your pencil sideways, like it doesn't exist below -2. In fact, it starts at -2. This is the first time it exists, and then it hits everything in between, and then it goes all the way up to +2, and then it does not exist above +2. So we will say that the range, I'll just mix it up and use some alligators. We'll say it goes from -2 and includes -2 all the way up to +2. Ooh, good old-fashioned space dolphin. Okay, when I hold my pencil vertically, like right here, the graph doesn't exist. Like it doesn't touch those x values, but the very first place it starts touching x values is at 3, and then it continues touching everything all the way out to +infinity, holding your pencil vertically. So the domain, maybe we'll go American on this one, is 3 all the way up to +infinity. Remember, not including. Then for the range, you hold your pencil sideways and you think, okay, here's the first spot where it exists, and that touches at 0 on the y-axis. And then as I go up, it touches all of these y values, and in fact, this arrow right here will keep getting bigger and bigger. In fact, it'll go up to +infinity. So the range on this one is that it starts at 0, I'll go American again, and it includes 0 and goes all the way up to +infinity, but it cannot include it. Last example, A piecewise function. I call these guys the Frankenstein functions because they're like a couple or a few different functions all sewn together. So between 0 and 2, the function is 2x. Between 2 and 4, the function is a horizontal line at 4. And then between 4 and 8, it's 1/2 x plus 2. Now, before we sketch this graph, I am going to plug in some values, like the first one, f of 2. Now, 2 falls within this range right here, so I'm going to plug that 2 into just the top function, because that's only where it exists. I mean, 2x only exists between 0 and 2, including 2, so I need to put 2 into that. So it's 2 times 2, so that's 4. Now, if I put 3 into it, 3 falls in this domain, it falls into that interval on the domain. And then no matter what you put into that interval, the output is 4. So this one is just 4. They're both 4. Then to put a 7 in, 7 falls into this zone. So I'm going to have to do 1/2 times 7 plus 2, which is 7/2 plus 2, which if I need a common denominator, that's 7/2 plus 4/2, and that is 11/2. So the answers are 4, 4, and 11/2. The last part of this, we're going to have to graph the piecewise function. So between 0 and 2, so just in this zone right here, going from 0 to 2, from 0, it goes up 2 and over 1, because the slope, the gradient, is just 2. So I go up to, start here, and then go up 2 over 1, up 2 over 1. Oops, no, I used different blocks, sorry. So go up 2 over 1, up 2 over 1. So in the first, from 0 to 2, the graph looks like this. Then from 2 to 4, it's just a flat line that goes just at 4. So from 2 all the way to 4, I'm going to connect this to here. It's flat. Then in the last zone, it follows the, it goes up 1 over 2. So from this point right here, I'm just going to go up 1 over 2. So we'll go up 1 over 2. And then up 1 again, over 2. And I think that takes us all the way to 8. So it's like this. So there is the graph of our piecewise function. I'll get rid of my highlights. Yep, that's what it looks like. Oh, I guess I could label it that this is y equals f of x. Okay, you guys, good luck with your homework. Please ask me questions in class.